Hello student, in this video I am going to derive the equation of the arc length in parametric form and polar form. So first of all, let us take this one parametric form. Now that means suppose x is a function of t, say x is given to be a function of t and y is given to be y of t, which is a function of t where t is a parameter. Then in this case, what is dx dt? Dx dt is equal to x prime of t and dy dt to y prime of t, or you can write this one, dx is same as dx dt into dt, and dy can be replaced by dy dt into dt. Now if you take this arc length dl here, then in the previous video I have explained to you how to derive equation of the arc length in Cartesian form. So for that one, dl is equal to square root of dx square plus dy square. Now from here you see that since x is a function of t, so you can express this dx as dx dt into dt, dy can be written as dy dt. So this will implies that dl is equal to, that means the length of this portion only, so it will be square root of dx dt the whole square into dt square, dt the whole square plus dy dt the whole square into dt square. Now this will implies that dl is equal to, now dt square is common, so, and square root of dt square will be dt, so it will be square root of dx dt the whole square plus dy dt the whole square into dt. Now this is the length, the arc length or the length of that portion only, that is this portion. But now from x is equal to a to x is equal to, from t is equal to a to t is equal to b. So what will be the total arc length? It will be from t is equal to a to t is equal to b. So you have to integrate it and get the total length. So therefore, the required length, arc length of the plane curve is equal to integral t is equal to a to t is equal to b square root of dx dt the whole square plus dy dt the whole square into dt. So this will be the formula for the arc length in parametric form. But now from this one we can also derive the equation of the arc length in parametric form. Now in polar form we have this presentation, x is equal to r cos theta, where r is also a function of theta, and y is equal to r sin theta, where again r is a function of theta. Now what you see this one, where in this case we have to find the arc length from this point, or from this point to this point. Why? Excuse me. That is this portion to this portion. From here to here. So now you see that the radius from here to this point, from the origin to this point here, is given to be r1, and from here to here is r2, where r1 r2 depends on the change of this angle made by this vector with respect to the x-axis. So when the radius vector is r2, then in this case the angle made is theta 2, and when it is r1, then the angle made by this vector r1 with respect to the x-axis is theta 1. So let us see what will be the arc length from this point to this point. That means from theta 1 to theta 2. So now let us see from this equation. So name this as equation 1 and this one as equation 2. From 1 we have dx d theta. Now here it is a product of two functions, r and cos theta, but r is also a function of theta. So in that case, you have to give one first as a constant. R into differentiation of cos theta will be what? It will be minus sin theta plus cos theta into differentiation of r with respect to theta. So it will be dr d theta. Name this as equation 3. And what about dy d theta? Dy d theta will give you what? Give r as a constant, differentiate this one, so you get r cos theta plus differentiation of r, then keep sin theta as a constant, so it will be sin theta into dr d theta. This is equation 4. So now let us substitute it in that parametric equation, but here you can see that in place of t here it will be theta. So now here the arc length dl will be equal to square root, that is in parametric form. In place of t, you replace it by theta, so it will be given by this one, dx d theta the whole square plus dy d theta the whole square into dt, but it will be d theta here. So now let us see what will be the arc length in this case. So substitute that one. What is dx d theta from this equation 3? From this equation 3, we have it as r into minus sin theta plus cos theta dr d theta the whole square plus, what about dy d theta? It is r cos theta plus sin theta dr d theta the whole thing square into this d theta which lies outside. So this will implies you that dl is equal to square root of, you can expand this one, you get r square sin square theta minus sin will vanish, then plus cos square theta dr d theta the whole square, then minus 2ab using the formula a plus b the whole square, so it will be minus 2r sin theta cos theta dr d theta plus now this term inside there, again inside the square root, that is r cos theta plus sin theta dr d theta the whole square. So if we expand that one, you get it as r square cos square theta plus sin square theta dr d theta the whole square plus 2ab, that means 2 times of r cos theta sin theta d theta or dr d theta into this d theta which lies outside the square root. Now let us further simplify this one. So this will implies you that dl is equal to square root of, now r square sin square theta, and here I have r square cos square theta. So you combine this one and this one, then you get r square into sin square theta plus cos square theta. Now note down here this minus 2r sin theta cos theta dr theta and plus 2r cos theta sin theta dr d theta. This can be cancelled. These two can be cancelled. And the other two terms that remained there will be this one. It will be where dr d theta the whole square is common. So we get cos square theta plus sin square theta into dr d theta the whole square. then into d theta, which lies outside the square root sign. So now what is this value? It is 1. Here also this is 1. So this will give you dl is equal to square root of r square plus dr d theta the whole square into d theta. So this will be the arc length in polar form for that small portion only from that small portion in that curve. So it will be square root of r square plus dr d theta whole square d theta. But now what will be the arc length now from theta 1 to theta 2? That means from here to here. So you just have to integrate that one. So you can write now. Therefore, the required length now from theta is equal to theta 1 to theta is equal to theta 2 is given by, let me take as L, because now the length will be bigger because this is for a small portion only. So it will be from theta 1 to theta 2 square root of r square plus dr d theta the whole square d theta, which is the required polar equation of the arc length of the given curve. So hope it is clear now how to derive the formula of the arc length in parametric form and polar form.